Now let's see how we can use the voltage division rule and the current division rule to analyze a circuit. Analyzing a circuit means we are finding unknown currents, resistors or voltages. So voltage division rule can be applied when the resistors are in series, and the current division rule can be applied when the resistors are parallel. So we know when the resistors are in series we have the same current, but the voltage is divided between the series resistors, and when the resistors are in parallel we have the same voltage across the parallel resistors, but the current is splitting. So that's why we are applying the voltage division rule to find the voltages across different resistors in series connection, and we use the current division rule to find how this current is split between the resistors. Now let's start with the current division rule. When we have the current division rule, we apply that to two resistors in parallel. When we have many resistors in parallel, we can simplify them to two resistors. We already know how to simplify, how to find the equivalent resistance when the resistors are in parallel. So now let's take that we have two resistors in parallel, and a current I is coming into this node, and this I is split between these two resistors. I1 is going across the R1, and I2 is going across the R2. To find the current I1, we can say when you consider I1, that is equals to the total current times the opposite resistance. So to find the I1, which is going across the R1, you have to use R2 divided by R1 plus R2. So the current likes to flow in the easy path. So when the resistance is less, more current is going. When the resistance is high, less current is going. That's why we have R2 here. So I1 is equals to the opposite resistance divided by the total resistance times the total current. I2 is equals to opposite resistance. When you have I2, you have R1 divided by R1 plus R2 times the total current. So we will apply this current division rule and we'll solve some questions, then it will be easier for you to understand. In this example, we have three resistors in parallel. We are going to apply the current division rule and find this I1, I2 and I3. To apply the current division rule, we should have two resistors in parallel. So we are going to combine two of them and make it to a single resistor to start with. So if I combine these two, that will be R2 times R3 divided by R2 plus R3. So that will be 400 times 600 divided by 1000. That is 240 ohms. So I can simplify this circuit to two resistors. So we have 4 amps coming in, and we have one resistor which is 200 ohms, and the other resistor which we have simplified as 240 ohms. So 4 amps coming in, and we have I1, and just take this one as I dash. So we can find I1. I1 is equals to, I1 is the current going across the 200. So it is equals to the total current times the opposite resistance, 240 divided by the total 200 plus 240 amps. So if you find the answer for this one, that is 240 divided by 440 times 4, which is equals to 2.18. So this current is 2.18 amps. Let me check whether we have done it right. 240 divided by 440. Yes, that is right. So 4 amps is coming into this node, and 2.18 is going this way, and the remaining 4 minus 2.18, you can apply the the KCL, or else you can find in the same time using the same equation, current division rule, but I'm going to apply the KCL. So 4 is coming in, 2.18 is going this way, so that this one here should be 4 minus 2.18. So that will be 4 minus 2.18, which is 1.82. So this 1.82 now coming into this node and splitting. It is splitting between these two. Again, we can apply the current division rule here. So I2 is equals to the total current coming into that node is 1.82 times the opposite resistance 600 divided by the total of these two now. So that will be 1000. So our answer will be 1.82 times 6 divided by 10. So that is 1.1 roughly amps. So you can see 4 amps is divided between the three resistors in this way. So this is 1.1. So the remaining, this going as I3 should be 1.82 minus 1.1. So I will write it like this because 1.18 is coming this way, and it is split between I2 and I3. So I2 is 1.1, so the I3 should be 1.82 minus 1.1, which is equals to 0.72. Yes. So you can see 4 amps coming into this particular mode, or else the current supply is 4 amps and it is split between 3 resistors in a way that I1 is 2.18, I2 is 1.1, and I3 is 0.72. If you have done it right, when you add all together, you should have 4. Yes, we have 4. So that is correct. Now let's see the voltage division rule. Voltage division rule is applied when the resistors are in series. So you can see R1 and R2 are in series. So to find the voltage across R1, which is V1, and the voltage across R2, let's take it as V2, you can find V1, that will be the total voltage times the same resistance divided by the total resistance. So it is different to the current division rule. When you have V1 here, you have the R1 here. Similarly, when you have V2 here, you have R2 here. In the current division rule, you consider the opposite resistance, but in the voltage division rule, you consider the same resistance, because voltage is proportional, or else voltage is equals to IR. So when the resistance is high, the voltage is high as well across the resistor. So we are going to apply this voltage division rule and we'll do some questions. Okay, so we have 15 ohms and 20 ohms and the total voltage of 40. So to find the voltage across V1, that will be total voltage times the 15 divided by 15 plus 20, and V2 should be 40 times 20 divided by 15 plus 20. When we add these two together, again we should get 40 volts, like in the previous question for current division rule. Whatever the current coming out should be equals to current going out. Similarly, whatever the voltage supplied by the voltage source should be split between the resistors, so the sum of that should be equals to the total. So you can put this value in the calculator and find V1 and V2.